All right. Hello, everybody. We are back for season 4 of Code Live with Google Cloud. Very excited to be here. I'm actually calling in live from Chicago. I'm still Aaron Wanjala, still the Java developer advocate, and I'm here with Mark.
Hi, I'm still Mark, or my name's Mark. Depends on which accent I'm using. I use that joke all the time. It never gets old. I am tech lead for video game stuff on Google Cloud. I'm having a day. Apparently, I can't form sentences, which is great for a live stream.
Yeah,
How are you? Yeah. Chicago treating you well, Aaron?
it is. It is. It's only my second time here. Love it.
Cool.
Love the office. So happy to
Nice.
be back and happy to be talking about, whatever it is we're talking about today. We we do have a topic chosen,
We
Ray
do.
on GKE.
Yes.
I barely understand it, so what is array?
That is a good question. So I will also be clear. I only sort of understand it myself too. But I have something I want to do, which I believe we can do with Ray. But we're gonna work it out as we go. Cool?
Cool.
Sound good? All right. So um I've done a lot of work like running like Gemini or actually other open models, something like Gemma, for example, on Vertex. So I've done a lot of work running things on Vertex. Vertex is great. Love Vertex. But sometimes you might want to run a model or train a model on GKE itself. There's a
Right.
variety of reasons you might want to do that. Some of them I know, some of them I don't, which is fine. So, and I sort of really wanted to start to pick apart that journey of running models on GKE and see what that looked like. And it seems like one of the big open source things in the Kubernetes ecosystem for seems like both training and maybe running models as well is Ray. So I thought I'd take the easiest approach, which sounds like is basically running a model with Ray. We're not going to go down the training path. That might take a long time. I don't know. Maybe we'll get there. Maybe we won't. We'll see how we go. And sort of see what we find out along the way. Does that sound cool?
Yeah, exciting stuff. And of course, as always, we welcome your questions. You're not
Yes.
interrupting. If you have a question about what something that's going on or an idea on what we should try, shout it out. We'll see if we can work it in.
All right. Let's see how we go. All right. So let's raise some stage. I have an empty project. There is nothing in here, I promise.
Up our sleeves.
Let's have a look. Do I have any clusters? I do not have any clusters. So I have clusters. That would be weird. All right. So empty project. And I barely know what I'm doing. So Ray is an interesting one as much as I know in that there is, and I'm going to make that bigger.
Mhm.
There's like Ray, and then there's also Cube Ray. And from what I understand, here we go. Okay, so let's actually read it. I'm not gonna guess because that's silly. KubeRay. So KubeRay is an open source Kubernetes operator that simplifies the deployment management of Ray applications on Kubernetes. We can actually pop that up in a sec. And so for people, actually, if people are watching and they're not familiar with what a Kubernetes operator is, I know this one really well. So basically, it's an extension of Kubernetes itself. And we'll probably see it in action where you can install new resources, basically like new names for what the Kubernetes cluster knows about, and then some software that reacts to that. And those combinations of what's called a custom resource definition, plus what we call a controller, which is just a piece of software that watches what happens inside the cluster, can cause Kubernetes to do custom things. And that's super powerful and really extensible. It's really nice. So it sounds like, here we go, perfect. The KubeRay core, official, fully maintained component KubeRay, 3 custom resource definitions, Ray cluster, Ray job, and Ray service. So what do they do? Let's have a look. And I'll make that a little bigger. Let's see what we, oops, wrong button. Ray cluster. Interesting. KubeRay fully manages the lifecycle of Ray cluster, including cluster creation, deletion, autoscaling, and ensuring fault tolerance. I do.
Sorry, as we're getting into this, we know it manages the deployment of Ray. Did we actually go into what Ray?
I don't know yet. No,
Don't know
I
yet,
don't
okay.
know what Ray is yet. I'm just picking at the top level things, and we'll see what that is. I don't know what Ray cluster is, but this just kind of sounds like it might be able to create Kubernetes clusters, but I'm not sure. I'm trying to just get a vague idea of what this thing does, and then I'll roll it back. Interesting. Okay, with Ray job, KubeRay creates a cluster and submits a job where the cluster is ready. Fancy. Ray service is made of 2 parts: a Ray cluster and a Ray served deployment graph. Okay, I don't know what those mean. Cool. All right. Well, let's look at what Ray is itself. Ray is an AI compute engine.
Hmm.
Okay, AI libraries for accelerated ML workloads. What does that mean? Ah, data, train, to, serve, and something called RLib. And then something about custom applications. Neat.
Interesting.
We are talking. I'm going to talk about serving. I think that's what we want. Let's have a quick look. Ooh, that's tiny. So RayServe is a scalable model library for building online inference APIs. So inference is like the act of doing prediction that a AI model will do. I have to like constantly be like, what's the difference between inference and training in my head? I don't know if anyone else does that every time I see the word inference.
Yeah, that's helpful.
Okay,
And
so you can. Sorry, go ahead.
as well. That's interesting. So you
What's
can.
that?
It's framework agnostic as well. So you could use PyTorch, TensorFlow, kind of whatever you want. And that's helpful to me too, because when you're talking about like hosting, running models, serving models, there are like a number of layers of abstraction you could be at, and TensorFlow kind of dials me in as to like how low down are we getting.
Okay.
That does give me some information about like what exactly we'll be serving here. Hmm.
Got it. Yeah, I think the thing that I'm thinking of is right now sort of some maybe open large language models because those are easy to kind of do stuff with to a degree. Um, okay, so this seems like there is this quick start here. I don't know. This kind of freaks me out a little. That's a lot of Python. So I'm not gonna. That's scary. All right. So I'm probably gonna like step away from that for a sec and say, okay, GKE and Ray. Okay, because I wondered if we were like, okay, we have a thing for this, and I think the answer is yes.
Yes.
So how do we make this easier? Let me grab. Actually, these two results look particularly good.
And we'll find out how easy it is.
Oh, look, and there's a whole bunch of and searching for ourselves, we end up finding ourselves inside ourselves. I
Yep.
just all the
Ourselves
way down.
and our teammates. That's fantastic.
Yeah, that's great. You actually should probably watch that with Mofi. All right. Let's make that bigger as well. All right. This page provides Ray operator. Ray is an open source unified computing for scaling AML and Python applications.
That's actually a great summary of what it's actually doing. Open source unified compute framework with a set of libraries to distribute the compute runtime across multiple nodes. Perfect. Everything you need to know.
Okay. It's there as probably nothing for today, but I do find it interesting that it's like AML and Python applications.
That's true.
Like, what does that bit
I
mean?
guess
But
that's the like custom application side of the serving diagram.
I guess so. Yeah. The Ray operator is the recommended way to deploy and manage Ray clusters on GKE. Okay. It uses kubeRay, which we saw before. Sweet. And then we end up with Ray cluster, Ray job, and Ray service.
Cool.
Cool. All right. This looks very similar to what we were talking about before. The Ray service lets you configure Ray serve applications, which I think takes us back to where we were before.
Yes.
Okay. Fine. Enable the Ray operator. Well, that seems like a good place to start.
Yeah.
Okay, so what do I need? Console, create standard autopilot,
And so
features, advanced settings, enable Ray operator.
Wow,
That seems remarkably simple.
Yeah, that is some like first class support. I didn't know it'd be to the point of a checkbox. I thought we'd have to like import it from a marketplace or go to like operators
and like install it.
Yeah, like find it. Yeah, anyways.
All right.
Great.
Let's give that a shot, especially if it's going to take a little bit to run in the background. Yeah, go away. That's fine. We're going to call you.
Can take a little while. Are we going to be using an autopilot cluster?
Yeah, of course.
Okay. Yeah.
I'm going to call it Romano, as in Ray Romano. No, I don't know if I can do that. Maybe I can't do that. Everyone loves
Ray.
that I feel actually I like. That's a better pun. That's just a better pun. There we go. Yep. I'll stick it in somewhere close to me. I'm on the West Coast. There we go. All right. don't care about that. Advanced settings. Here we go. I did set it. Okay, so this is actually, here's an interesting question. Where did it create an autopilot? Okay, it does create me an autopilot by definition.
Yes.
All right. Advanced settings, target release general recommended. That's fine. AI machine learning, enable Ray operator. Yeah, do all the things. Give me all the things. What else is in here?
Fantastic. Okay.
I'm just poking around now. I don't need a service smash. I don't need maintenance windows. Okay.
Networking. Do we have to make any choices to make it actually accessible?
Let's look at the question. No, we don't need control plane access. Yeah, we can just use the default subnets. Like everything else is fine for now. I mean, you might want to tweak that if you're doing it for realsies, but.
And do we actually get a front end by default? Do we actually have like a publicly accessible IP for the?
I don't know.
I don't
I think this just installs all the stuff.
Fair enough. We'll get the cluster running, and then we'll get it accessible.
Yeah. Let's hit create.
And if memory serves, that can take like, I don't know, anywhere between a couple and a few minutes to spin all that out.
Spinning. Clusters being created. All right, cool. You know what I'll actually do in the background as well is I will want to poke around inside it. So let me provision my Cloud Shell as well, so that can happen in the background. All right, so while that's running, we'll let that do its thing. All right, so far so good.
And we do have more docs to read, and we also have some choices to make. Have you thought about which model we'll be serving?
You ask a good question. There is a quick start here.
Yeah.
That looks pretty good. How to serve a large language model. Gemma? Could have been that Google.
Yeah, let's do Gemma.
That seems very reasonable. Also means I don't have to like, I don't know if there's anything I need to like agree to.
Yeah, that's fair.
It's
just a coincidence that Gemma rhymes with llama.
Gemma rhymes with llama?
Doesn't it?
Does it?
Kind of.
Does it? I guess.
Yeah.
Okay. Model multiplexing and model. Okay, this could be interesting. I don't know what some of those words mean. I don't know what it means by model multiplexing.
Model multiplexing. I don't know. Actually, do we want to ask Gemini something?
That's literally what I was going to do.
Yeah, because I know like networking multiplexing and demultiplexing, but I don't know how that would map directly to a model or even inference. Like it doesn't seem like a direct analog.
Yeah, let's ask the question because I actually have no idea.
Mm-hmm. Whoa.
All right, let's. Can I move that across? No, but I can pop into a new window. Does it have my history? No.
That's okay. We can ask for a 3-sentence summary of these concepts as well.
Oh, it's over here still. It's fine.
It's a treatise.
Technique where you combine multiple machine learning models to handle different aspects of a task. Oh, okay.
Okay, then I have done multiplexing actually in the past. I just didn't know that it was.
Yeah, it's almost like HTTP routing for different things. Essentially,
Exactly.
It sounds that way.
Yeah.
Model composition is about building a larger, more complex, combining small pre-trained models. Models identify objects and image, then feed that information to another model that generates. Oh, interesting.
Fantastic.
Oh, okay. So model multiplexing is okay. Yeah, it's like you have a mux. So like this request goes here, this request goes there, this request goes there.
Yeah. So it's like this is an image understanding request. This will go here. Pass everything you want into my service, and I will find the right model for you.
Yeah. Whereas
is the router pattern.
Yeah. Yeah. Exactly. Same. Composition is more like almost like you're setting up a workflow. Like the first thing goes into here, which then hands to this, and this hands to this, and then finally you get a thing at the end.
Yeah, I have a demo on YouTube of building a RAG application where we do a composition use case where we say we want to be an interior designer. So take a picture of a room, understand it with Gemini Pro Vision, then pass that description into like a RAG, like a and then put the final response together with Gemini Flash. So that was kind of we're decomposing the problem and feeding each part of it to a different model.
That is interesting. I'm curious to see the trade-offs of just like doing that by hand inside like a little program versus having something like Ray do that for you.
I feel like, I think there's got to be some significant savings because that implementation, it was interesting. it was clear, but it wasn't fast. And being able to do that
Mm.
within one like within one round trip to the network, you send one request to a cluster,
Oh, I see what you're saying. Yes.
internally sends those requests, and then sends you the response. Sounds fantastic.
So yeah, rather than bouncing between a piece of software and like multiple models, it
Yeah,
just goes model to model to model to model.
yeah. That does sound like a very good like next step for performance. I We're gonna learn today how much is involved in getting that going. um,
That is true. If we, as depending on how far we get,
yeah, yeah.
we're still waiting on a cluster, so that's fun.
I think
Uh,
we probably got another minute. I've seen it take around 8 minutes to create an autopilot cluster.
oh, okay, you remember, but it hasn't installed Ray. The Ray should be. It's just stuff in the cluster, so in theory, it should be pretty fast. Anyway,
Installing an operator, yeah, I don't know
it should
how much
be.
that
Yeah, it
is.
should be pretty quick. All right. All right. So the Ray framework provides an end-to-end AI platform for training, fine training, and inferencing of machine learning workloads. Sweet. You can serve popular LLMs for Hugging Face.
Interesting. Because from Hugging Face,
So am I signed into Hugging Face? Log
and see, the Hugging
in.
Face experience is kind of what I was expecting to bring in an operator like Ray. I was expecting it to be like, do you want which operator do you want to use? Like
Sweet. I'm
Argo
just gonna
or
log in the background. Don't mind me.
absolutely. But no, it just said checkbox here enabled Ray. Um, so interesting. And as far as the like supplying the model ID, um, I somewhat expected it to be like, from whatever marketplace like Vertex, but I mean, I think most people just default to Hugging Face. So
Yeah. So if you're not familiar with Hugging Face, though I'm sure a lot of people are, it is like a central place for models and data sets and a bunch of other fun stuff.
fantastic
Um,
design, by the way, very modern, very.
so there's
I
like,
like web design, so yeah,
and so here we have like Gemma, for example. It has a lot of the details of it. These are interesting things. So like how you run it. I'm
ooh,
going to end up writing Python, aren't I?
yep, probably.
I don't know how to write. I mean, I can kind of write Python. All right, we'll see how this goes. This should be very entertaining at the very least.
Okay, Gemini knows how to write Python for us.
That is true. So we'll see how that goes. So anyway, yeah. So here's stuff on Hugging Face. All right. Although I feel like we also have Gemma stored. Anyway, it's fine. It's fine. It's fine. Everything's fine.
Okay,
All right.
step
The Ray
one,
framework.
mostly complete.
Create an autopilot standard cluster with Ray with add-on enabled. Done. Deploy a Ray service resource that downloads and serves the large model. So that's actually kind of cool that you don't have to manually do this, because I feel like I've tried that and it's a pain. And then we'll deploy chat interface and dialogue with LLMs. All right, this gonna work. That's gonna work. I sure you have a Hugging Face token. I probably do. I am not going to share that with you all.
That's fair.
If not, I will pop off and do that. That's fine.
So now, when you say that we have deployed the Ray service,
Yeah, I wanted to poke around inside the cluster once it was up and running so we can see what's going on.
and what is your preferred method? Do you just usually use kubelet, or you run?
Let's see if it'll let me do this. Yeah, usually I'll just kubectl and poke around. It's not running yet, so I can't access it. Of course. I can do that. Do we have K9s on here? No.
That was my tool of choice, but
I don't mind. Actually, I've been trying to use K9s a little bit more, but I'm very used to just using kubectl. The other thing is we do have a lot of handy tools within the actual IDE here. You know what? I'm going to pop you into a new window. It's just going to be way easier. There we go. That's better.
Yeah.
Come on. Can you show me anything? Oh, here we go. Okay. Hey, there we go.
Yeah.
There we go. There we go. Perfect timing. Yeah. So let's have a look. I'm actually very curious. All right. So connect. Let's just copy that. That makes life easy. That probably needs to be larger. Where are we? There we are. Nope. Terminal settings, text size, largest. That's decent. Okay. We could also install K9s if we really feel like it. But.
We could.
All right, so we have a thing.
70 seconds old.
We have some namespaces. Anything? Okay, we have GK array system. All right, and I'm going to assume there's no pods in it like here, but I'm guessing we do in GKE
Array system.
array system.
Nothing. Do we have any services in that namespace?
Let's be cheeky. Well, actually, hold on. Was there something, I'm pretty sure on enabled array operator, verify. There we go. Yeah, it says that array operator is indicated. All right, let's have a look at that then. Describe, what's our cluster name? Everyone loves. Oh, yeah. Because everyone loves array. Oops. Yeah. Where did I put it? Region US West 1, I think.
Yeah.
Is that where I put it? Or, you know what? We could just do it through the console. Look for array operator. Okay. Array operator is enabled. Okay, but actually, you know what's a better way of actually checking this? Because we know there's custom resource definitions. And
we're in US West 2.
Oh, there we go. Thank you. We should see some kind of array. Here we go. Array clusters, array services, array jobs.
Perfect.
There we go.
Cluster services. I think that was listed in the doc somewhere.
Okay, so there's no array clusters. There's no array services. And there's no array jobs. All right. Okay, cool. All right, well, at least we have a bit of an idea.
Yeah.
The system's a bit small, so let's make that a bit bigger. Okay. Nice. Let's go back to what we were talking about. All right, so we've done that. In theory, I should have a Hugging Face token. We might come back to that. Sure, you have GPU quota in my region. Ooh, I didn't use US Central 1. We use what? US West 2?
US West 2.
Let's have a look at quotas. Please don't tell me I put it in the wrong region for that.
Well, did it say we need to be in US West 1 or Central 1?
No, but I know GPU can be a bit of a pain.
Yeah.
And it's a brand new project, of course, as well. GPU. No, that's not what I want. How do we? Okay, is there a way to check that as a good thing? Sure. See GPU quota. Let's see what we got. Metric.
GPU.
All right. Name. GPU. Ooh.
I'm not seeing an obvious quota resource there. Let me see. Okay, GPU quota autopilot.
There you go. Give me a region, a location. Dimensions, location, US West. 2.
Okay, so Okay, I have a list of GPU quota names.
Oh, I can get like some L4s. Is that what we're using? Yeah,
Yeah.
we're using L4s. It looks like it should be okay.
I think
This
we are
is
gonna be okay.
where are we? L4.
0 out of 100%. Yeah.
That's committed. I don't know about that. I don't really care about committed. Just NVIDIA L4s. Yeah, I can get 8. I don't think I need more than that. Hopefully.
I doubt it. And if we use 8, we won't need them for long.
That's true. Okay, so we should be okay. We're not doing anything too thingy. But yes, GT quotas are absolutely a thing you need to check out anyway. So good. So we should be fine. We'll be fine.
If you did need more than 8 for any reason, which would be reasonable, you can request an increase in that same panel. There was just another tab.
Yep.
But that would be, I think, be subject to availability.
Yep.
Yeah.
Oh, interesting. Okay, so there's they have like a script for this.
Neat.
That seems boring. Let's work out how it works. That seems boring.
That's not Evil Knievel enough for us.
Yeah, that's no fun. Okay, so but I will have a look at it. So let's go samples. Like, I know that's a good size already. And where was that? Because I want to understand what this is actually doing. And I want to go into Kubernetes engine samples, AI, ML, Racer, LLM. Can I copy paste that? Will that work?
I would slash it. Oh, there it is. It came up right at the last second now.
There we go. Okay, so boom, boom, boom.
And this is for Llama.
Yeah, so this is, interesting. So they've got actual examples for a variety of different composition, modeling, all kinds of fun stuff.
So we're going for Gemma 2B?
Sure, that seems reasonable.
Yeah.
Okay, here's array service. Oh, this seems too easy. I don't like it.
No, fair enough.
All right, but that's okay. You know what? Let's go easy. I'm not going to install it directly, but I want to see maybe if we can like at least reverse engineer what is actually going on.
Or you could put on a blindfold if you want a little more challenge.
What is this?
Tensor parallelism is set to 1.
Oh wow. Okay, this is more complicated than I thought.
It also it expects a GCS access for something, so that may be a more involved. What containers are they actually trying to serve?
You ask very good questions. All right, so array service, there's a spec, there's a serve config. I don't know what that does, but I guess we'll go work out. Applications.
Yep.
Interesting. ML GKE array serve. You can go away from that. That's a name. Okay. Array locus 1, bunch of array stuff. We have 1 GPU. All right, it's fair enough. Whatever. Runtime environment samples.
Ray
archive.
Interesting. Where is it getting the ray head container?
Where are you seeing that?
48.
Containers. Name ray head, image ray project ray ML. So that's just the name.
There we go. Okay. Yeah, perfect.
Yeah.
Thank you.
But there's a cluster config. Is that okay? So it sounds like we have some understanding of concepts that I think we need to really get, which is like, what on earth is a ray cluster?
Yes, that's important.
And there's a lot of interesting stuff in here. So many things. This almost seems like a repeat of what we had before.
Mm-hmm. So I guess this spec will have to match what we've already. Wow. Yeah.
Okay, so we're gonna learn some stuff.
I like it.
Okay. Do our docs explain these? This is a good question too. Claims a directory for each model, array service configuration. The configuration for each model includes array serve deployment, the Hugging Face model ID, the array cluster, the underlying array cluster, and resources required for each component, which includes head and worker pods.
Very cool.
But what does that mean?
So
so assuming you install this, you can kubectl get service, and you will actually get a service
running and
back.
serving that.
right? Which you could then be like, hey, should this be? Oh, interesting. So this is the operator part. So you install the Ray service. The Ray operator is going to say, hey, I see this Ray service, and then I'm going to create all the things I need inside the cluster to make this a reality.
Yeah.
That seems very fair. Okay,
Um,
cool.
what I wonder is with that script that we have, we'll have a worker and the head. We'll have workers, worker pods, and one head. So the one head is, I'm assuming, routing requests between those. How many worker pods do we get by default? Two?
Don't
Let's
know,
see.
but how do we specify it? Okay, this okay. This is going too far. Is there anything extra here? Customers use flavor cluster, custom resource. All right.
Looks like it's one, actually.
I don't know what I just did there. All right, let's testing array server application. Interesting. Yeah, I am confused. All right, so with the array serve, you define, apparently there's a bunch of Python.
That checks out. Can we zoom in here?
Oh yeah, for sure. But it doesn't seem like that's. I just want to understand the concepts of what we're looking at.
Right.
Key concepts. Okay.
I hope it explains what a worker and a node.
Right. Or
Because I can assume that on a serving, like a distributed compute service, it's going to be node creation and management.
so Kubernetes itself, I think in theory would handle the nodes.
That's true. So I guess it has to be more tailored to what exactly we're passing through for an AI/ML workload.
Yeah.
I don't.
And it does also seem like there is a from the example we saw for at least on the LLM side, there's like a special array thing that just does the pull down an LLM and make it run.
Yes.
Right? Like that seems to be a thing. But I want to understand, like I would love to be able to create this ray serve thing myself.
Yeah.
That would be ideal. Yeah, here we go. All right, ray serve default values for deployment is a good starting point for explanation. Dope.
We also apparently have a Terraform project for this, which is neat.
Ray serve deployment. Why do I have this weird feeling that this thing here is the code version of what we would say through a Kubernetes custom resource definition?
Yeah. This does seem like you could translate that into YAML pretty.
Right? They look kind of the same.
It's almost the same content that I would put into YAML for this kind of service. So
yeah. So okay. Well, then how do we find that?
Find the YAML?
Okay. Ooh. Yeah, well, like the reference to the YAML. Like what is the YAML supposed to look like? Is there like so there's a array service quick start. Oh, here we go. Ooh,
Yeah.
ooh. Array service quick start. Oh, this is interesting. Okay, we're in like you might not be able to see it on the stream, but like the docs just went from where we are like cluster Kubernetes getting started. Here we go. So there's a whole here we go. I think this is like the magic section.
Yes.
Which is the ray on Kubernetes, and then
this is where the rubber hits the ray.
Thank you. I appreciate you. Interesting. Okay. Yeah. All right. This is yeah. So if anyone else is looking at this and they're like, "This doesn't seem easy," that's because it's not.
Yeah, this is
Um,
not simple.
this is not simple.
It
Okay.
does seem powerful once we can get it going.
Apparently. So I've been told anyway.
Yeah, it sounds.
I believe so. All right, so we use the kuberator is the recommended way to do so right on Kubernetes. That makes sense. We use the kuberator iterator. It's already there.
Yeah, have that.
Kubernetes neighborhood array. Okay, let's sort of a head node pod, collection of worker nodes, blah, blah, blah. All right, so there's all these things. Okay. Okay.
So
3 distinct Kubernetes custom resource definitions. That would be lovely. I would like to use those. That would be great.
The Ray cluster quick start will that give us?
Maybe that is the right place to start.
Yeah.
All right, fine.
Yeah.
Fine. Okay.
Oh no, I was wrong. Because we're looking to just serve the model. So it says using Ray service to serve models, Ray cluster to develop applications.
Yes. But I feel like, oh, interesting. Ray service has 2 parts, a Ray cluster and Ray serve. So it sounds like, okay, so thinking Kubernetes paradigm, like a deployment has a pod template spec inside it, right? It's not a pod, but you can kind of embed it. It sounds like it's kind of embedded. So if I like it gives you these samples. I really would like to not have a sample.
That's fair. Why don't we read the YAML is trying to apply to us and then see if we can whip one up ourselves?
That's true. Okay, let's have a look at their service sample. Maybe that's kind of fun. And maybe it's like something very easy. Ooh, that's huge.
Wow. There's a lot here.
Yeah, what is this serve? What? Okay, you know what? I'm going to take this. I actually have IntelliJ open, so I'm just going to do a little scratch because it'll make life easy. Gemini cards can go away, and that's just a little bit easy for me to look at and just.
So it wants to give you 5 copies of the Mango stand as their sample. That's very interesting.
Serve config takes a YAML multi-line scalar, which would be a Ray serve multi. So you've got YAML inside YAML.
Mm-hmm.
But okay, that is a choice.
Yeah.
All right. What the?
So wow, this is much like okay. So this is a directed acyclic graph test project.
Yes.
Fruit stands in a fruit market. Interesting.
In the energy containers. This is very interesting. I don't know if I want that. Wow. Okay. Ow. Really need like just like a hello world.
Yeah, I was sort of expecting a hello world container.
Like, yeah, as an example. Like this is
it's a lot.
It's a lot. Where were we? Let's get back to. So if let's say I do that for argument's sake. Server is healthy and ready. KubeArray creates a headed service and Ray serve service the Ray service custom resource. Boom. And I verify the status of server applications.
I mean, I am with you on the hello world container. Although it seems like what we could do is serve this multifaceted fruit stand service, check that the rest of the cluster is working, and then replace that service with a simpler container or one that's more directed to our ends as a fallback if we want to. Mobile net example.
Ooh, is this what I want? That's what Ray clusters. Yeah. Or is this literally what we just saw? Yeah, what is that? This is very interesting. No, this is literally what we just looked at. Okay. Upgrade guide, manage research services, Ray cluster configuration. server text summarizer. I just want something really simple. Like what's a really simple. One CPU node, one GPU node. That's fine. Kubernetes operator done that. I want to see what this looks like. This looks easier. This whole serve config v2 thing kind of is interesting. Pod template. Oh, here we go. Group head spec that gives us a pod template.
Those look significantly easier.
Params template. So this, what's the difference between these two? Are these like the dashboard?
I can also send you a fast API demo deployment that is just a hello container.
Ooh, yeah, send me a link.
Yeah, so that is in the, yeah, there you are.
Beautiful.
In the fast API integration tab, that looks, so that is the whole
okay. Yeah, I confused.
Run it locally and clear it over HTTP.
Yeah. Okay. So brains. All right. So this is like, I'm trying to see if there's config. Yeah, this doesn't look right. Like, is there an actual reference? Max use config, specify parameters, serve deploys. This looks kind of the same. Huh.
On the getting started page of that Radox page.
All right, I'm coming back to this quick start that we had because I don't know.
Yeah.
All right. Maybe the right answer is I actually just do the thing.
Yeah, we can follow this.
Let's follow this and see what happens. I'm very
yeah. Yeah, we can create the circuit for our Hugging Face credentials, and then that actually solves the problem of how to use it and give access to it without exposing the token. And then
yes,
we can pick our model.
Okay. All right. You know what? Let's give it a shot. I'm so very
gcloud command to create our node pool for GPUs.
Well, I don't need to do that because I'm autopilot. So I've already got that. We just need to specify. So we can specify on the pod whether there's a GPU or not. And so that should take care of having the GPU stuff.
Agreed.
All right. Oh, all right. The other thing I am going to do, though, is I'll just dip for a sec. Let me create my token.
And as far as we have the model selected, this seems sensible. There are a number of ways to do this, and I really hadn't considered that the serve concept would contain a cluster by default inside of it.
Oh, yeah.
Like it said, there's cluster, serve, and a third thing. And then the serve contained the cluster and a job. Oh, yeah, the third one was job. So just interesting how these match with each
other. What's my cluster version?
Did you need to share your screen again?
Sorry, I'm hiding stuff in the background.
Fair enough. Cluster version 1.30.5.
5. And then we got our project ID, which is macro GKE.
And I do wonder, I'm looking forward to having an example of an auto-scaling cluster that's serving a model. Because how fine or coarse can those auto-scaling steps be? I imagine it's bucketed where, the model, it takes up a bunch of resources when it starts. So that's one, I'm guessing it's like the model takes up the majority of the node's resources when it starts because that's the nature of the workload. But then when requests slow down, when network traffic hits a threshold, then it steps it up and it creates a duplicate for us. I don't know. That's what I hope to get answered by the end of today's stream.
Okay, actually that looks pretty good. Bam, let's put that back up. All right, so I created my secret. It did the thing. And it's hidden and it's somewhere, and I can always delete it, so it doesn't really matter too much. Okay, so array server deployment, I'm going to use Germa2B as we said before. Oh, I need to clone this repository. I was missing something.
And
yeah, that works.
We will find out what that sample is. The LLM sample.
There we go. And then I assume I need to go into Germa2B or whichever one I wanted to use. Pin my Cloud Shell so it's easy to find. Did that. Deploy it. All right. Okay, so it's literally.
We actually did read through that YAML before.
Yeah, so actually we can open editor. That up. Hello, editor.
I think it's coming, but
there it goes. There it goes.
Open folder.
Where are we? Kubernetes.
And in case folks did not know, in the Cloud Shell Editor /OSS world, folders are workspaces.
That is true.
If you open a different folder, it assumes that is the world for the time of the editing session.
AML. We are doing GKE Ray. There's a few things in there, so let's just do that because that'll.
Yeah.
There is actually some interesting stuff in here as well, so I'm gonna leave it alone.
Cool.
But we're going reserve LLM. We're looking at Germa2B. There's our race service. We can make this a little bigger. Oh, you are now huge. That's a bit better. Okay, all right, so that's doing something.
I am also going to point out that the model, the service that we just deployed is maxing out our quota.
Oh, it is already?
It is one replica that has an actor option for up to 8 CPUs. Or no, GPUs, sorry.
It says 1. Okay, so that says 8 CPUs, 1 GPU.
That's good. I thought it was 8 GPUs. I'm like, wow, from the start, okay.
Well, actually, there you go. Let's have a look at our. I mean, that's still spinning up, but we can have a look at our quotas as well. So we can actually clear those out because it'll give us the quotas that are actually in use. And look, okay, we're fine. Yeah. Everything's fine.
And almost all of those quotas are adjustable, so not a hard limit.
Exactly. Let's see if that's taking a minute. It may be, especially because it's probably spinning up nodes. We can also look at this through. Let's do this here. Kubernetes engine.
Yeah.
See how we're going. Let's go to workloads. And I'm willing to say that is currently on schedule because it's not ready yet. Yeah, so we're spinning up some nodes in the background.
Fair enough.
Oh, see what it says. You're not ready. All right. So look at the event stream on that.
Interesting.
All right. There's usually some fun stuff in there. Oh no, we're not getting a new node.
Okay.
Interesting. All right. It's still pending. It hasn't died yet.
It's working on it.
Ready preemption.
It said preemption is not helpful.
All right. I'm going to ignore that for now.
Yeah.
We'll see how we go. Okay, that's still container creating, which means it's probably pulling down that whole model still. But actually, I'm going to look at that over here. Let's look at the event stream, actually. See if there's anything interesting in there. Okay. Oh, this has triggered a scale up. So that's an autopilot thing. It will actually trigger the scale up if it's there's not enough nodes, which there probably aren't. And I'm willing to bet that the other pod is probably waiting for that node to also spin up as well.
That is fair. I don't know. I am a bit naive on how much in terms of resources Gemma 2B should take. But like I'm looking at the YAML we just deployed and it says we have 2 vCPUs and 8 gigs of RAM. And I would expect a model that size to take almost all of that up, maybe more. And so I'm not surprised that it triggered the auto scale. But what is it scaling to? I would love to. We'll feel that out.
Well, actually, you know what? We can actually see because we have pod details, so we can actually see what it's deployed. So if we let's go. Let's say it's this one. I'm not sure which one is which, but that's fine. We can actually look at the resultant YAML. And if that's too small, it may well be.
Yeah, it's quite
tiny. You can go away.
Gemini's just trying to help.
I'm just here to help.
Resource adjustment.
So this is a pod. And let's go all the way past all the annotation stuff because that might be important. And all that's all just management.
We could search because it's pretty regular with the units. We could go like capital G quote.
Here we go. Resources. Here we go. So it's looking for 2 CPU, a gigabyte of ephemeral storage, 8 gigabytes of memory. That all looks
same. So
that sounds like that lines up, right? Like that's what it was looking for. So it resulted in what we were looking for.
I don't know if it actually. Well, I don't know. I don't know.
And then there's a bunch of status values as well.
We'll see.
Yep, that is. Okay.
Pulling image ray. That is a helpful event log.
How big is that image? Or is it that
I don't think it would be that big, but
this image is deprecated.
Okay.
Great.
It's arriving just in time.
Thanks, buddy. No, it doesn't actually say how big they are. Oh wait, here we go.
In the digest, yeah.
Oh yeah, they're chunky. Look at that, 5 gigs.
5 gigs. Okay. Interesting.
So they're a hefty little image there.
And I'd like to do
some of these are even bigger. Okay, so these are nightlies, but I don't know.
That brings up a good question. I'd like to do a speed test from a Kubernetes cluster, pulling down the images. How fast is the network?
It
when
depends.
when you're hunting
So,
something down like that?
if you're pulling from Artifact Registry, obviously that's a bit faster because it's right next to it. But also, if you're pulling from Artifact Registry, we can do image streaming, which means that if we have enough data to start the application, we can start it up before the full image is downloaded. So we can do some sort of preemptive magic about how
Cool.
that works.
I wonder if
So,
does that work with like image composition when you're trying to like
ooh,
use a builder image to build your full application? But I guess builders are usually pretty small.
change with unready status. Okay, we got
Another
some.
thing,
Oh, we got some stuff running.
time to dig around the YAML. I noticed that it seemed to be deploying the same image for multiple containers. It was like, okay, Ray head. Here's the same 5 gig file we just talked about. Like here's the image, and then for like I'm wondering if these
Well, there would be. You know what? This is
like for
condition. This is actually not. Here we go. There's two different containers here.
yeah
There we go. And they do both seem to be running. They just don't seem to be ready yet. And there's
yeah
an exposing service. Hey, okay.
Fluent bit. I assume that would be just our logging container, but um,
Well, it's probably the
but I saw
something.
that Ray head was one container, and the other one was LLM was the name, and it was also the Ray ML image. Interestingly, we'll
Okay.
see what that means.
Well, there's only two containers in this view. So there may be something in the race serve about how they set that up.
Mm-hmm. Oh, interesting. And it listed.
Okay. Oh, we're up and running proper.
Wow.
All right, that looks good. Executed.
So in terms of,
Oh, jeez.
oh boy,
Oh, it got evicted. What? Okay.
if we scroll down,
Oh, that's fun. Okay, so the Ray Hack exceeded its load limit. Okay, that's not good. But is it just run? Sorry, you wanted me to scroll down. I
no,
apologize.
I actually got it. In terms of like wall time to get this deployed, we're talking about 8 minutes from hitting the deploy to us exceeding our our storage limit. So, but it is showing up. Oh boy.
Ooh, that's a lot of stuff. All right. Whee. So is this okay? So is this running? That's still unschedulable.
We refresh. Is it still unschedulable?
Says unknown. Ooh. All right. Sounds like we're debugging stuff today.
Yeah. I mean, maybe that's why it was.
So is it like in a crash late back off? Exit code 137. Restart count 1. Okay. So, ooh.
Lack of memory. So yeah, that exit code means it was terminated for lack of memory. So that wasn't a mistake. It was literally hitting the limit. We could
edit the YAML and see what happens.
we can just say YAML and redeploy.
Code. Yeah, I want to see. I got an echo. All right, let's have a look. Okay, well, I'll tell you what.
It does actually confirm the theory I was having. I was like, wow, is Gemma way smaller than I thought, or are we gonna blow past that limit? And
yeah. What do I need the ephemeral storage for?
Good question.
Oh, here we go. This looks like it. All the positive nodes are Invictus tests use the nodes with low resources ephemeral storage. Pods that use empty dir volumes that storage quotas will flood the storage with filling errors presage. I wonder what it uses it for. I wonder if it's downloading the model into it. Okay. I keep doing that. Whatever it is, I keep clicking. Does that every time. Yeah, let's clean up some of this stuff. If anyone has any ideas in chat too, always nice.
Feel free.
Container runtime to kill the public specified grace period. Oh wow, it's really having a good time.
Fully shut down. Yeah. Okay.
So there, container blah blah blah. All right. Well, let's tell you what. Yeah, let's bump it. Let's see what happens.
It asks for more memory. We can do that.
We can do that. It seems pretty grumpy. All right, ephemeral storage. Let's have a look at yeah, you. Give me you. Give me. All right, so let's find ephemeral. That's not anywhere. But I thought I saw it as ephemeral storage. I feel like
in YAML, yeah, I did see that.
I saw something. Nope. No.
Okay.
I swore I did. Here we go. We are Reserve LLM. We applied, making sure I got the right Gemma 2B IT, which is what we're looking at here.
Resources, limits. So what if we just raise those limits? Like
that sounds good.
Do we also
where do we do that? Okay.
Yeah, I see two places. Do we have to both increase the limit in the spec and on the ray actor resources field? Ray actor options.
Yeah, right. So it does seem like it's in. Okay, so there's Ray head. We saw that come through. It's not this one. It's not Ray ML. Apparently.
Yeah. Okay.
Yeah, that's got way more. That's got the GPU on it. That's got the memory. So I'm guessing that's what's actually serving. The model, unless this is suddenly magically self-healed. No.
I would be shocked.
All right. No, I don't care about that. For Kubernetes, how do you increase the ephemeral storage? I can't remember the API off the top of my head. So,
not a chance.
And I kind of wish I'd pulled this down locally. But anyway, it's fine. Can't directly ephemeral storage is new resources and managed by the online infrastructure. Oh, goody.
Interesting.
Oh, okay. All right. Well, let's have a look for something that says, all right, Ray on GKE ephemeral storage. That was for quite a few batch processes run GKE. They need between 30 to temporary disk space to execute. So the resource request of the relevance containers, resource limits, ephemeral storage. Ooh, what is that? I think Gemini Lives. Yeah, we should be able to set ephemeral storage.
Default request. Well, let's see.
Resource limits. You know what? I'm just going to look at the Kubernetes API. It's easier. Kubernetes. Also, if I go in here, does this give me... Not this one. I want... It's Ray head. Now, I really should just pull this down locally.
Request storage. There we go. Yeah.
I should have done this locally. Anyway. Pod spec. Containers.
Assuming a generic volume is valid, we should be able to go resources request storage.
Brains. Actually, make it bigger so you can see it too. Where's that one? Resources. Let's have a look at resource requirements, claims, limits, objects.
I think.
Oh my god. Local ephemeral storage. Thank you. Yes, let me. Yeah, that's it. Ephemeral storage. Okay. And just so I've got it right as well. Whoops, I'm looking at the wrong thing. So I might end up pulling it over there as well. It is specifically, if you look at the events, Ray Head. Okay, so that's the one that's, nope, it's not that one. I keep doing that. It is Ray Head. It's this one here.
I'm assuming it tried to create an empty directory on startup and it sees the 1 gig.
Let's say 5GI.
Yeah.
I did 6. I don't know why I did 6, but we'll do it. And we'll do both. All right. Let's try that now. See if that makes any difference.
We shall see.
It didn't like it. All right, let's go back. Probably because I changed it. So let's go back to our workloads.
Running.
That looks pretty good. Is it going to stay that way? It's kind of my question. Because I feel like it was.
That's new. Like we didn't. Did we keep?
Is it like consistently running? Is the question.
Yeah.
Stay that way. All right, something's happening. Cool. Nobody has any questions on stream. All right, cool. I don't know what it's doing, but that's okay.
I did send you a sample as well from, it's more of a generic Kubernetes example, but yeah, request.
Yeah, ephemeral volumes. Yeah, got it. This is looking better.
Yeah, it is.
All right, let's see what we have. Anything interesting in logs? This is looking better.
It's actually looking like it exists.
Okay. So we have something running. We're not entirely sure what it's doing, but we have something running.
We will poke at it soon. Ideally.
Cool. But we still have this issue with this one being unstable. Okay, let's have a look. 0, 1 nodes in mesh point fitting selector. 0, 1 nodes. Match pod node affinity selector.
Pop. Didn't match. Okay.
Oh. Did I miss something in this? When I created, I created my own cluster. So let's have a look. Cluster version. This all seems fine. Like there's nothing special about this. So other than the fact that I stuck it in a different region, but like on the old. Refresh that page. So you don't see my token anymore. Ow.
Application service status.
Okay, well, let's try that.
Bring service.
Let's get the service. Actually, make that a bit bigger. I have a feeling it's going to fail, but we'll see.
I think it will return something. Nope.
Well, let's have a look. All right, so it did a bunch of stuff.
And I saw Hugging Face there, but does it actually reflect the increased limit?
Well, what it should say something. It should say status healthy, status running. And as we can see, it is not.
Status deploying, yeah.
It's doing something.
It's still on the way. So last time it took about 8 minutes to attempt to deploy.
There's our token. This is like, yeah, this is exactly what we set up.
I am seeing the 6 gig ephemeral storage on it as well. So that's
nice.
It's trying what we asked it to, and we'll see how it goes. Now, does the cluster have to be kicked off independently? I wonder. Do we have to trigger like a matching upgrade to the cluster as well?
Seems strange.
To Ray cluster. I would have. Well, no, it actually doesn't seem strange.
Yeah, the GKE autopilot should just work.
Right, but I think there are like the word cluster is now overloaded because
No, true. Yes, I see what
there,
you're saying.
there's
Yes.
the GKE cluster, and then there's also the Ray cluster.
Okay,
And
so yes, the GKE cluster should, but there's something about
yeah.
one node didn't match selector. Okay, let's search that. Or
How fix? Gemini, how
node
fix?
affinity. Yeah, Gemini, tell me how to fix it.
Oh,
That doesn't seem right.
no.
All right. That seems wrong. All right. So what I'm going to do instead is pop back up here because we are looking at what's the name of this one? This is details. Does it come from something? Give me like an image or something that I can. Okay. So LLM is the name. Okay. Here we go. Perfect.
Yes.
So worker group specs. Template. Okay. This looks like a pod template spec, I guess. Yeah, it actually looks exactly like a pod template spec. So it's called LLM, blah, 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 blah. Requests.
Interesting.
L4. I wonder, can it not get the L4 GPUs? Basically,
I would have expected it to say, I can't request a GPU. Like,
it would give you a
or
better, yeah, it would give you a
or
better.
something, or like unable to request this. It's just saying doesn't match the pod's affinity / selector.
All right, there's a link to learn more. Read the part of the mission selector does not have minimum availability. That's what it said, right? Does not have. Oh, it didn't match nodes affinity selector. Preemption not helpful for scheduling. So like 4. Yeah. Cheer autopilot cluster. I wonder if, yeah, let's have a look at Quota. Let's have a look at Quota. Quota gets you every time. I thought we saw that we had GPUs in that region.
We do. We have the ability to use 8. So let me actually send you another link here.
Yeah, do it.
So it's looking like this is an out of resources failure. But yeah, it's just using a different compute class. I wonder if we just need to duplicate the resource specification that we had in the other pod.
In what way?
So we had the limit like 10 lines, 20 lines above.
The ephemeral storage thing?
Yeah, we added the ephemeral storage limit in the other container. This is the same image. Does it also need the ephemeral storage in this container?
So this is Ray ML 2900. Where is the other one? Oh, good point.
Yeah.
You know what? I'm down to give it a shot.
I'm frankly shocked that the first one worked so fast to bring the pod up. So maybe this one will similarly go up the light.
I don't know if it makes any difference, but I am down. All right, let's do it. I keep doing that. I really should just have used my local, but anyway.
Hey, well, we're learning.
CTL apply. There we go.
All unexpected.
Yep. I wrote stuff on the wrong line. There we go. Okay, try that.
Last time it sprang to life in about 4 seconds, so let's see. Let's see if it's that fast this time.
Let's have a look. That is apparently terminating. Interesting.
That's not quite the effect I was predicting.
hoping for, but hopefully it comes back in some way, shape, or form. Yeah, it doesn't even know what it's doing.
Well, that makes all of us.
It seems like I'm guessing. Yep, it's gone entirely. I'm guessing we'll get replaced very shortly.
Did happen briefly.
Yeah, new version. Okay.
Last time.
All right, that's all coming together. There you go. So you're back up. Good for you. This is still unschedulable.
Unschedulable. Do we have to manually bring it down and get it back up?
I was gonna say like let's just
because it said
just kick it.
Yeah, it said unschedulable since null or like a date and then until indefinite. So maybe it was just never going to try again.
Yeah. All right, I created this again.
18 seconds of pending. It's an appropriate amount of pending.
It still shows up as unschedulable though. Why are we not getting GPUs?
We're having the same, yeah, infinite. We're having the same interactive selection error. Interesting.
Oh, this is kind of cute.
One node.
0 nodes of one preemption is not helpful for scheduling. So it's like not. It should be scaling up a node that has a GPU on it, and it kind of hasn't.
If you run GPU workloads, the requested GPU might not be available in your node location. Which locations is the NVIDIA L4 GPU available in? Is US West 1 or 2 one of them? Let's see.
How do you know this? Where are you looking? If you want to share, go right ahead.
Yeah, no, this is on the troubleshooting guide. So let me actually see if I can poke around on how to do that.
Feel free to share your screen if that's something you want to see.
Yeah.
You can.
Let's do it.
Are we just running a cluster in the wrong place?
We may be. And it does give me like some tips on how to find that. So let's see what that looks like. So it says, yeah, you can place GKE pods in specific zones, when to use specific compute classes. This might be the right page, but we'll see. Workload issues.
I would kind of have hoped that it would be like, hey,
no,
you don't have a GPU.
If it would say, oh, you're trying to deploy it in a like region that doesn't support it. Or
we've run out of GPUs. We don't have capacity right now. Go somewhere else. Give me something that tells me that would be good.
Yeah. So multi-zone affinity YAML. No, this is slightly off topic for what I'm looking for. I'm really looking for which zones have which. Okay, let me look for this. NVIDIA L4 GPU zones. I just want to know which zones I'm allowed to deploy it in.
Well, I think, yeah, you're looking there. When I looked at the quotas, it said that we had them in US West 2.
Oh, okay. Well, that seems to answer the question, honestly.
Well, let me double check it, but I'm fairly sure. Name, let's just say L4. I don't want committed. I just want NVIDIA L4 GPUs. Yeah. In So I'll show you what I'm looking at here. You can actually see like there's our quota. We're not using any of them. Now, it's entirely possible that unfortunately we may have just stocked out and we don't have any anymore.
But even then, I would expect a stock out error rather than like node affinity.
Right? Unless there's anything on the cluster itself. Let's have a look.
Oh.
Says it's healthy. Oh, you got something good?
I think I found it.
Yeah, take over. Take over.
Let's see if we can parse this table together, because there's a lot of table here.
You can share your screen if you want.
Yeah, here we go. GPU, here we are. You're seeing that. GPU regions and zones. So there's a lot of L4 family results. These are for virtual workstations, though. So GPU.
We don't really worry about that. Yeah.
Yeah. Select a GPU machine type. No. Why is L4 not here? GPU availability by regions and zones is exactly what I want. North America is the broad domain. So if I go to US West 2, oh,
B and C have them, or something.
okay.
We're looking at L4s though.
Yeah, these are zones. So okay, so it says for more information. No, that's just on what a zone is. I don't need that.
Well, actually, out of curiosity, if you were to scroll down and just look at US Central 1, given that's where the quick start was, and I just want to see if there's anything different there. Up.
Central 1.
US Central 1, they have like
everything.
So that's really why they keep trying to push us towards US Central 1.
Yeah. And so it says, for G2 accelerator optimized machine types, which include the L4 GPUs.
G2 is what we're looking for.
Still, it says G2, and it does not say that in West. It says in West 1A, actually. Maybe we should be okay. Which zone did we end up in? Because if it's C, apparently we're out of luck.
Well, C has it, A has it, B has it. I think.
We're good then.
In theory, it should be there. No, we're in West 2.
West 2.
And that does not.
West 2 is spotty.
West 2 doesn't have anything.
Yeah.
So we're in like completely the wrong region.
So, lucky us, we picked the best one.
So that's, you know what? If you're still watching, this is the takeaway from this. We're in totally the wrong region.
Yes.
Just the error message is not good.
Yeah, interesting. I say we try deploying this in another region.
Maybe US Central 1.
Actually, wait a minute. Would we have to recreate the cluster in a different region?
We would.
Shucks, that would take a little bit.
Which is a little frustrating.
Hey, well, it goes to show, I guess, the quick start regions sometimes have a lot to do.
All right, you know what? Yeah, let's get rid of everyone loves. I'll have that run in the background. Okay, let's follow. Where's my quick start? Yeah, that's fine. Brains. Okay.
And the regions and zones page defaults to CPUs. But in theory, we also have a regions and zones page just for GPUs.
It's called US Central 1, advanced settings.
You want to take the screen back?
Oh, yes. I'm just creating a new cluster and deleting the old one. So doing the same thing, and we'll call this everyone really loves. Yeah, we'll create that. I think I turned it on.
This might be the place to put it.
does seem like I'm just like let's go to the place that everyone really loves it.
No, I
Apparently,
mean,
US Central One is the place that everyone really loves it.
a warning. This might be the place to put it. If you check off, like for example, you're checking off Ray. Well, hold on, that might be too specific.
I do wonder if we're going to run into that same ephemeral storage issue that we had before. But
I wonder. But yeah, no, I'm trying to think of like what is the improvement that can be made here. Like, should we have, when we selected that we wanted a GPU enabled autopilot cluster in a region that didn't support all families, when would it have? When should it have surfaced that?
yeah, we were like, hey, we're going to use Ray. We're probably going to use a GPU.
And it said, great.
Are you putting it where it should go?
Yeah. Well, good to know.
That is valid. Also, that error message is
not it. No Definity. That did not trigger anything for me versus.
I had an idea just because I'm really used to autopilot. And so when looking at, where are we? All the way down here, this bit, that sort of tells me, oh, there's a node selector there.
Mm-hmm.
But we actually look for affinity. There's actually no actual affinity here. Unless it could be on the pod itself. Oh, this looks like the whole thing, yeah.
Yeah, as far as I know, that
All
was...
right, well,
if not for that troubleshooting page, I don't think I would have picked it up, but hey.
I'll have to wait for that to come up.
I'm expecting that to take another 4 minutes.
All right, well, while that's happening, I want to dig back into RayServe and see if I can have a decent understanding of exactly what it's actually doing behind the scenes, because that bit is I'm trying to find a good example. Well, not an example, actually, maybe a good explanation. Mm-hmm. We might be able to reverse engineer it to a degree.
I like that idea.
Or let's look for certain config. Let's look for Ray, and then like this is a. Here we go. Setting up. Okay. All right. So. All right. So we install that. Represents the configuration that RayServe uses to deploy the application using serve build to print the serve configuration, copy paste it directly into your Kubernetes config and Ray service CR.
Interesting.
I don't know what that means. I guess serve build would be part of like Ray's command line interface.
Yeah, I guess serve build is the command we're running on the image, the RayML image that we're deploying in containers. So we're bundling the extra YAML to say, I'm going to pass this to RayServe to actually serve the app you're talking about.
Yeah.
That's the YAML within YAML implementation.
And there's a lot of querying, but like, I am somewhat coming to the conclusion that to understand how to run Ray on Kubernetes, you need to understand. Coming at it from a Kubernetes first perspective may actually be the wrong path from a learning point of view. It may actually be that you need to come in from how does Ray work and then come back around.
Maybe, but I feel like that is still valuable, like, you know.
Yeah.
Right here, because, you know, I feel like only people who have the Kubernetes backing would consider Ray as an option. So
yeah. Like everything is Python, which makes it,
which is, yeah, it is unclear how that would come into play initially, but
how to play on Kubernetes.
Scalable Ray applications. And then there's a Python package to just deploy directly to Ray as well.
It does seem that way. I think I was reading something and it looked like you could connect locally to a cluster that ran Ray and make it do stuff.
Yes.
Which is cool.
Yeah. The fast API example that I sent was one such example. I believe it was like, just go ahead and deploy it to Ray. I'm like, oh, okay. Yeah, Ray.
Yeah, because here you're installing Ray serve, and I'm guessing then you're connecting.
Serve.run app. So that's the.
Yeah, but how does that work in terms of like Kubernetes?
I'm guessing that when RayServe receives that application, it.
Yes. I expect it to be further along than this, but that is okay.
That's okay. That's what learning in public is all about here. And I wonder how our cluster creation is going. But
yeah,
it's probably still spinning.
Quick look. Still spinning. How are we doing? Health checks. Okay. So I always forget that it actually does give you a thing there, which is nice.
That's, yeah, I didn't know that actually.
We can try deploying this again. I have a lot of questions.
Me too.
And
if you in the audience have any questions, feel free to fire them.
We can try and look. Yeah. So like this bit is interesting. Like what is in this zip, for example? And why a zip of all things?
Yeah.
Is also a good question.
The LLM deployment.
Maybe it says.
This is 404.
Yeah, that's because that'll be the raw, probably the raw thing. Oh, maybe not. If archive. Oh, I know what it is. It is not that. If you want to download this, nope, that's not the zip. Yeah, you can pull down the zip file. It's literally pulling down, I think, all the code.
Okay.
I could be wrong.
Of the whole Kubernetes engine samples repo. And then
tell you what. See how big it is. Mictor. How big is it? Okay. Oh, really? No 7C? Ah.
You can do unzip.
I'm lazy.
Fair.
Because I use it a lot. Also, it does a listing of what's inside there, which makes it I don't want to actually unzip it.
Well, that's fair.
Whee!
Ooh.
Yep.
That's about 4 gigs.
No. No, that's bytes, I'm pretty sure.
Okay.
Because the file itself
400 kilobytes?
It's 5 megabytes.
5 megabytes.
There we go. But yeah, okay, so it's all the files. Yeah, it is all the files. Okay. There we go. Yeah, it's everything. It's just, it pulls down all the files. Okay, so that's what that is. All right, so like it pulls down all the files and then does what? AI, ML, GKE, array, ray serve, LLM, serve model. Is there something in there? Ooh, this is interesting. Okay. This is interesting. Give me the where do we go? There's something about that. I know we're running out of time, but there was something. Brains, come back here. Ray serve, give me that. So AML, GK ray serve, LLM serve models. So ray serve models.
I'm not seeing any crashing in the logs yet.
Oh, that's good at least. Well, I haven't run anything yet on there.
Yeah.
We have a cluster yet? Oh, we have a cluster. We have a cluster. We have a cluster. All right.
Is liveness probe failed, but that's not a problem. Let's see what we got.
All right, so let's connect to that cluster. Oh, that's tiny. Sorry, let's throw that up. All right, so we're connected to that cluster. Cube CTL get CRDs. Actually, let me grab Ray. Sweet.
Things.
All right, I'm just gonna apply what we had. Oops.
So path. We have to go AML, LLM. Yeah.
Oh.
We are in. Yeah.
Oops. Why you hate me? Oh, I know why. Different stuff. All right. Now let's apply it. Okay. I still have that ephemeral storage thing going, but
We'll see if that.
at least that's going. I'm trying to work out what this thing here is. While that's running in the background. So sorry for jumping around a little bit. Okay, so here is AIML GKE Ray serve, which matches AIML GKE Ray serve. So I'm kind of like, what is it pulling in to do something with it? And it's like, I'm running an application. I'm like, okay. I'm guessing it's like, oh, cool. This is telling it, this is how I run probably a Python app, I guess.
Yep.
Which is okay. Rayserve LLM. I think that's what we want. Yeah, Rayserve LLM. Inside that, serve.py. Hello. Okay.
Construct a VLLM deployment, which to a VLLM project.
What is a VLM deployment? I don't know, but we will find out.
Is that like? It's not like LVVM. It's a virtualizing for LLMs. Let's see. That's my guess.
My dog is driving me. What are you eating?
It's a serving engine for LLMs.
Oh, I see what you're eating. Okay, so and that would be okay, Ray import serve. So like this is tying together the Ray Python libraries with the Kubernetes bits.
Yes.
I guess.
It is creating a deployment of a serving engine for the LLM.
This is where my Python is kind of trash. So model, and we pass in the model ID. Okay.
Have we done that anywhere? Passing in the model ID?
Yeah, it comes through. Comes through here. There's that model ID they pass through. Okay, so this is in Python code. It pulls it down. I'm guessing it's doing the work to pull through what the gemmer ID is, and I'm assuming that all kind of works. But let's see if any of these workloads are actually doing what we want now.
Configure.
That's different. Secret HF secret not found. Yes.
We do have a secret though. Does it have access to it? I guess that's
no, because it was in the other cluster. I hadn't recreated it.
That would do it.
Secret. Let's see if that works.
Amazing.
I assume the environment variable is still there. Actually, I don't know if it is.
Wow. Actually, it was a separate window, wasn't it?
Yeah, it was in this one. That might be the wrong secret. All right, let's have a look.
Well, you could, yeah.
Oh, this looks promising.
Yeah.
All right, well, let's see the logs. It may fail. I don't know if I created the right secret. We can always delete the secret and try again.
It crashed pretty quick if it was trying to access a secret and doesn't find. Like
that's true. It should just like go into a crash leave back off or something.
Immediately.
Let's see some logs. No logs. Okay. Events. Continue LLM. All right. Secret not found. I have a bad feeling of the secret is wrong. But that's okay. That's an easy one to fix.
I guess
Running.
it depends now on if
it's not
multiple
ready.
cloud shells automatically tmux variables between each other, and they might.
Yep, here we go.
Okay. Needs GCS access. Have you run ray start? That looks like a good error message.
Okay. I would have assumed whatever that means is something to do with what's what I'm looking for. I'm going to assume that the ray operator would do that. Cube ray would do that.
Yeah. I wouldn't expect us to have to manually run ray. Oh, one started.
All right, one's going. I have a really bad feeling that secret has the wrong data in it.
Wouldn't it have crashed while trying to start the head then?
I don't think head's the one. I think this is the one that does the actual work.
The worker one, yeah.
This one, because this one
isn't. I may have just missed it, but didn't we open up the head one there just now?
Yeah, this one's the one that
GPU group.
If I look at the YAML, go away with them.
The search secret is there? I guess.
Brains. Maybe I'm totally wrong. I'm not sure.
Hugging face.
Okay.
But...
here we go. Let's do that.
Good call.
Great. All right. It's not ready, which tells me it's probably still pulling it. But if it's working, it might just be pulling down the model.
Really slowly, yeah.
Really slowly, and there's no way. Okay, so it's not going to be part of this, but
it should be in the logs. Yeah.
Yeah, but it may not have those logs. All right.
Process the driver.
Bear with me 1 second. I'm going to check to see if the token was available. I'm just going to drop off screen.
Yeah, we'll be able to check the environment variable, but yeah. I mean, let's see if I can actually research if this variable would be present. Tmux cloud shell Google Cloud.
We call it HF
token. Does it say anything about? It uses Tmux, correct? Which now allows it to improve persistence across browser tab sessions. Fair.
Yeah, it's not going to do it.
Variable.
Yeah, I did it in the wrong spot. Ah.
All
right, let's see if I can recreate it.
That's a shame, because yeah, it does.
It keeps showing it on screen. That's hilarious. HF secret. All right, if I delete the secret, will it let me? Oh,
hey.
There you go. All right. This is the one that has it in it, so that should be better.
Good.
All right, so let's go back over here.
Or will it try? Will it already?
Ugh.
Maybe it's trying to bring it up with that new secret.
Yeah, I'm gonna. I was actually gonna delete both of them and just see what happens. When in doubt, unplug it and plug it back in. Because this worker, I'm pretty sure this worker is the one that has the GPU on it.
I believe so. That is the GPU group. Running? Container LLM running?
Oh, still unready though. It might take a while for that model to come down though.
No, that may have been out of date because it said container LLM has status unready. But wouldn't running be different than ready?
Now we don't have. Oh. I think I broke everything.
We're getting progressively less ready as we go.
So this one, Rayhead is still unready. Anything in the events? Logs.
To connect to this Ray cluster.
Cool. Oh, okay. So you could actually connect to the cluster.
What does it say? What are the steps to connect to this Ray cluster?
I don't know how that. I don't know if how that works with KubeArray, but anyway, that's all right. It's definitely doing something.
Can you expand that log entry?
Oh, all right. So that one's running.
That one's running. The head is the worker running. Not yet.
Yeah, I mean, the model is large. So it may just be like, I'm pulling it down and it's going to take a really long time. I'm not going to be ready until it does.
What if you view logs on the LM container?
Yeah. I wonder if this has a... Or what is it? What is it taking?
Liveness probe?
Yeah, or /live. I was going to say, yeah, probably check from the config. But yeah, this one, let's have a look at logs. It still has this GCS thing.
Sorry, what I meant was if you scroll down to the container LLM, there's a view logs, or I guess container logs would be equivalent, but yeah, like if you in the containers section, there's view logs beside the running LLM container. I wonder what those logs are saying.
Oh, this, I think it's probably exactly the same. But we can have a look.
Restart count to 0. It is the exact same. It is the exact same.
Yeah, it's the exact same.
Interesting.
Interesting. Okay. It is running. It's just not ready. So, okay. What I wanted to know was, what? Yeah, let's have a look at the YAML again.
And I am going to look at what those instructions were to connect to the Ray cluster from that one log output.
Oh, yeah. Yeah, expect containers.
Readiness probe HTTP failed with status 503.
Where did you see that?
I'm seeing it in the everyone really loves app errors.
Oh, and look at this is very interesting. So the liveness probe is actually trying to run a command.
Yeah.
Like a wget command. That is.
A wget to the local raylet. Interesting.
Yeah, it does that and then grep success.
Wow. Simple.
That is.
Easy does it.
Interesting.
Yeah.
Yeah, here we go.
Workloads.
This is assuming I set up this secret correctly. Just double checking it.
Oh, okay. So it's saying container status unknown with exit code 137. That is the out of memory error.
Okay, my secret looks like it's correct. I'm just.
But we have the same ephemeral storage spec that we had before, don't we?
Yeah, I put it up at. I put them both up at 6. But this doesn't tell us anything, unfortunately.
Sure does not. Surely it does.
It's considered exit code 137. Ray exit code 137. Container failed. Oh, out of memory.
Yeah. And we had that earlier, and we resolved it by increasing the resource limit.
Ah.
Pod local usages exceeds the limit of 6 gigabytes. Wow.
Okay. Well, this at least we know how to fix.
Yeah.
This is the other one. So I think this is not Ray Head. Ray Head's fine. It's this one down here.
More than 6
Let's just bump it to 10. Let's go all the way.
Apply. Oops, we've done too much applying recently.
There you go.
Ray surface. Am I? Yes, okay.
I don't think we can go above 10. That was what I was seeing in some other stuff. Now this is all going to run again. If we at least just get this working, I'm very happy. I don't know if we can call it, but like at least if it's like the pods are running.
The pods are running. That would be nice.
Yeah.
We are in the home stretch here.
Maybe. Maybe.
Possibly.
I give it a definite maybe.
I'm gonna give it a definite yes. I can feel the.
You feel good? You
this
feel good?
run is anointed. I can tell you.
Okay.
Running on the head.
All right.
What are we doing?
All right, that one's running. That's a good start.
I am following the logs. No, maybe not. Maybe that's not what we're hoping for. The error message, the logs coming out of the cluster worker group are so interesting. It says this command will block now forever until terminated by a signal.
Yeah. Okay.
And it says to terminate the Ray runtime, run Ray stop. And it says Ray runtime started. But then it says, hey, some processes that the driver needs to connect to have not registered with GCS, so retrying.
I am very curious if they're just warnings that show up that possibly mean nothing.
Yeah,
Could be wrong.
Have you run Ray start on this node? And it's like, no. Why would I have?
Okay. Let's clean up a little. Going back to get this. Just to.
Let me search this error message as well.
Yep. The other. Yeah, where is this bringing itself down to? Request. I will also completely agree that my Python is trash.
Allow me to send you a GitHub issue thread.
Ooh.
That talks about Ray, like this error that's coming out of our worker GPU group.
Yeah.
And it says that, I tried running Ray start. So this person connected to the node, tried running Ray start, failed. But then when they stopped their Redis service from following I think this example is either the same or it's similar to what we were after. This tutorial. No, this tutorial no longer exists. Never mind. But yeah, they had to stop another service before being able to restart theirs.
Right. Is this Ray or Ray on GKE though?
No, you're right. It is just Ray.
This one. Let's have a look.
This is apparently
okay. Well, it hasn't died yet.
That's good.
I'm kind of taking that as a win because before it died, like it just ran out of room, which makes me it makes me think that it's pulling down this what is it, Gemma? We're doing
Gemma
what?
2B.
Yeah, right. Gemma 2B, wherever it is that I can't find. Here we go. And like, if we look at Hugging Face, how big is that? I keep showing my access token. Stop looking. It's fine. I'm going to delete it as soon as we're done anyway. Oops. Gemma 2B. I think it was that one specifically. Yes. Okay. Files and versions. Like how? Like there's at least 8 gig in here. I'm just looking at it right now. Probably close to 9. Is that coming down to ephemeral storage? Like if that's pulling down, that might be kind of
yeah. Actually,
it would take a little while. It'll take a little bit to come down.
Absolutely.
Which also makes me wonder.
Well, hold on. Is this like the way I'm counting this? It's well over 10.
Right. And is there anything in this code, not that we can touch it, because it's pulling it down from here, that specifies?
I wonder if when it says GCS, is it talking about cloud storage? Is it expecting us to put this into cloud storage, these resources?
Well, I think so. This is my thinking on what this actually does. Is just interesting on itself. The serve config is what is like, hey, here's some Python code, run it, please.
Yep.
And where do I get the Python code? From this URL. Here's a zip file with all the code in it.
Yeah.
And we're saying here's the import path, and that's what's saying what does it. And like there's this thing. So it's actually serving the model. And the Python code itself is going and doing the work to pull down
the model,
which I can't find where that is happening. Model equals V. Unless that just
VLLM deployment bind. That might be it.
Maybe that just does it.
VLLM is it's a serving engine for.
Well, actually, where's the Hugging Face? Wouldn't it need the Hugging Face secret? Exactly. Thank you. That's what I'm looking for.
And
it just doesn't seem to exist anywhere. Model. Name a path of the Hugging Face model to use. Directory download and load. The way it's defaults to the default cache of Hugging Face. Readiness is failing. All right, at least we're seeing. Yeah, that readiness thing is not working like at all.
Not at all. Not as we'd hoped. No. Yeah, it has had a good several minutes to come up, and I don't see it doing so. So
it is running though. Let's see if there's anything new in the logs.
No. Yeah.
You're having a look.
That as well. Interesting.
Yeah, that was not as useful as I was hoping.
Oh, you know what? Okay.
We have something interesting.
Maybe. So I have from VLLM's source a reference to HF secret token. It seems to just expect that environment variable to be present.
Oh, so it's just like knows. It's like,
Yeah.
hey, there's a convention, go do it.
Yeah. So maybe that is why the bind doesn't require the specific authorization secret. Yeah, on what line is that? Line 47 of the YAML that I just linked. Or not YAML, no, 47 of the README that I linked, or the RST that I linked.
We're assuming this is also the same thing, but yeah, okay.
Yeah, so as far as I can tell, like Ray is serving the model with VLLM, VLLM deploying with Kubernetes. Here we go on line. If you go to code, line 47, it shows where it says Hugging Face token secret.
Oh, secrets optional required for authenticating models. You're not using gated models. Got it. Oh, I don't know if Gemma is gated, actually. They may not actually even need a token.
Yeah, what the heck?
It just like does it. See, this is, to be maybe a little blunt, this is a nice README. Like this, from someone who comes from Kubernetes, I'm like, oh, I could do this.
Yeah.
This doesn't look too bad. Like I can, it says, okay, load Kubernetes. We have a persistent bonding claim. Like we need some data. Yep, sweet. I need a secret. Cool. I create a deployment. There's an image that I can use. I can tell which one I want.
Yeah.
And like, boom, like just done. Awesome. This is really nice.
That is.
Um,
I can see why Ray would have gone with VLLM.
that makes sense, right?
Now, I'm less clear on how exactly. Like, I have a feeling that they were somehow expecting us to connect to the container and start it in a specific way. I thought that would have been done for us.
Died again. Guessing same thing. Yeah. Wait. Well, I thought I fixed it.
Yeah.
Oh, that's head though. Oh, that's head, not worker GPU group.
Interesting.
All
So
right.
even the head exceeded the 6 gig.
I think I might be at the realm of I give up.
Yeah.
How do you feel?
I think that we have kicked the tires and found that they are hard.
They are hard tires.
And yeah, I feel like I learned a bit about like these concepts and have more of a grasp of what Ray stands to be doing.
Yeah.
Yeah. TBD.
Also, which region to run things in? That would be
Definitely.
definitely look at that guide for which GPUs you want, and have a look at it there, and make sure that that's the one you want.
And the position actually flipped, where before we were unable to get a head node running, head pod running at all. But then, or no, we were unable to get the worker pod running. We had head running, and
We had head running. Head was running, right?
It was running, and now we have worker running, but a head isn't reachable. So it's interesting.
Okay. Fascinating. Cool. All right. Cool.
I think this may be a a tune in next time situation, or maybe
Yes,
we'll revisit this topic at a later date.
at
And
a later date, or here's one we prepared earlier, and be
yeah,
like, hey, we got it working.
yeah, perhaps
Um,
a continuation tweets or blog post is in order. We shall see.
yeah,
This is an interesting area. Um,
unless I missed something, but I don't. Nothing. No, no. Yeah, it doesn't look hard. All right. All right. I think it's trickier than it seems. There is more than meets the eye.
yeah, but I feel like I am more informed about the concepts, and yeah, I. It may also be just that the image we were trying to deploy was deprecated as well. Um, we did see that at some point.
We did, didn't we? You are 100% correct. If I look at that, it is. Yeah, it just blew up. Ray Project, Ray ML. Let's see if I can duplicate that real quick. This image is deprecated. Yep.
Usually when you deprecate something, you'll link to something else.
Sorry for 231.0. I don't know what version of Ray we run or what version of Ray exists. Let's have a look. 39. Okay.
Hours ago.
Build Python 3.12. This is package in array environment. These. Interesting.
What should we use then? Should pip install Python packages on top of Ray? Oh,
You should build your own, I guess, and then run it yourself.
well, that's not as convenient as having one package, one image to install. we can do that.
Maybe another day.
Yeah.
All right. Cool.
Well, I should read that, but why post a little more clearly? Because I still have questions.
I have so many questions. All right. Cool. Well, at the very least, we learned things. Stuff happened, and we worked out where GPUs exist in Google Cloud.
Yeah.
And
very valuable list. Refer to the regions and zones availability page before doing resource-specific deployments.
We checked our quota. We had a look at the quota. We were like, okay, the quota looks good. Interesting that we're listing quota for regions that don't have those things.
Yes.
That's confusing. Okay. That's loads of fun.
Good to know.
All right.
Well,
sweet. Well, Aaron, I appreciate your time.
Thanks for taking us on this journey. And yeah, I feel like I understand Ray better. There's still more to learn for sure, but hey,
yeah, I'll keep playing with it, and we'll see what happens.
Excellent.
All right, fantastic. Next week, what are we doing next week? Since we have everyone here, just as a reminder, because I can't remember.
Yeah, let me go to my season link. Actually, I don't have it. Our next episode is about. Jeez, oh man.
Got it there. Quickly.
I don't have it.
I believe in you. You can do this.
I will find it.
Will I beat you? Here we go.
No. I just had the open code.
Here we go. I have it. Whoops, scrolling down. Episode 2. There we go. Serving a really large language model. Right. Serving a really large model with leader worker set. I don't know what those are, but you and Mofi. Oh no, me and Mofi. I'm going to be doing it.
Yes, it's a leader election concept. That does sound interesting.
Is it leader election? Is this leader? I don't know. I
believe it is.
Maybe I will learn things in that will help me in this.
Yeah. We're gonna learn how to pick one for consensus building amongst many possible services. That'll be very interesting for those in the GKE land, and I'm gonna tune in myself.
I have no idea about this either, so we'll find out,
So yeah,
which is kind of
there
fun.
it is.
I get to ask all the stupid questions.
Yes, which is what we do best here.
I think so.
And yeah, thank you all for joining us again. Tune in next week to learn about that.
That, and check out the playlist for this one as well, because there are multiple episodes, some of which will definitely go better than this one.
Well, we we came, we learned, we didn't get
Yep.
the feeling, but hey, you know,
Fantastic. All right, cool. All right, well, Aaron, thank you very much.
absolutely. Thanks for
All right.
driving, and we will see you all next time.
See you all next time.
Adios.